Let me redo the question. Because I really want you to understand and appreciate this whole idea of drawing world diagrams. You must understand that what I'm trying to do is I'm trying to draw on the same, first let me just concentrate only to first half. On the same XCT. So you can think of it like this, that you have an observer which is at rest in the lab frame. And it sees a particle V moving. A particle moving with a velocity V. Right? So there is this S prime frame of reference, which is the rest frame of reference of this particle. And this is the S frame. I want to see how, so if I go to S prime frame of reference of this particle, it will see its world map like this only. It will see its world map as X prime and CT prime perpendicular to each other in its own frame of reference. What I want to do, what does the problem really want you to do is, how would its world map, which looks like this in S prime frame of reference in the rest frame of the particle, how would it look like? How would this world map appear to this person standing in the lab in S frame of reference? That is, if I was to draw the coordinate system S prime on S, graphically, how would it look like? You can also think of this as graphical representation of Lorentz transformations. That if there are two coordinate systems, S and S prime, which are related to each other by Lorentz transformation, how would they look like? Just like you have been doing this all throughout your 3 years, is trying to draw on a Cartesian coordinate system, how would spherical polar coordinate system look like? Right? Or how would cylindrical coordinate system look like? So now on the frame of reference S, I'm trying to draw how would S prime look like, where S and S prime are related to each other by Lorentz transformation. That's exactly the way to understand the problem. It's just that the way I posed it, it looked like as if I'm looking at a particular particle. But what is that really, what particle that really is? That particle really is your S prime frame of reference. So if I want to draw the world map of the particle on the world map of this observer, how would they be related to each other? They would be related to each other by the Lorentz transformation. So basically, I want to graphically represent these two equations. To draw X prime CT prime on a coordinate system X and CT. Just like if you have an X prime CT prime coordinate system which would represent simple rotation by an angle theta, how would you draw X prime CT prime? You would just draw X prime CT prime. If they are rotated about a fixed axis perpendicular to the plane of the board, you would say my X prime looks like this, my CT prime looks like this, and this is the angle theta. And then you know what is the matrix relating them. So, or in other words, I give you the matrix, the rotation matrix, and I ask you to draw X prime CT prime. Now, I'm exactly doing this problem. Is I'm giving you a matrix. That matrix basically relates X prime CT prime, and I want you to draw X prime CT prime on x and ct. Do you really understand the problem now? Okay, so now I want to represent x prime axis on this xct diagram. What would x prime axis mean? X prime axis would mean ct prime is 0. X prime axis would mean ct prime is 0. Then how is x prime related to x and y? So that I can draw x prime on this coordinate system. How is x prime related to x and y? X prime is related to x and y. If I put ct prime equal to 0 in this, it's going to give me gamma x prime ct gamma beta x prime. Right? Now, how do I draw x and x prime on this? I want to find what would be the angle between x and x prime. So angle between x and x prime, and let's say x and ct and x prime. How do I find the angle between x and x prime? Now I have to think what really is x prime. So x prime is the world line of a particle which is at rest in S prime frame of reference. It started at some x prime equal to some initial value of x prime at time ct prime equal to 0. Now since it is at rest in S prime frame of reference, it always remains at x prime. And you see that this x prime is like a world line of a particle whose coordinates are always x prime 0 moving with velocity v. So it's rectilinear motion. So x prime would be a straight line. First thing. Right? And what would be its angle with respect to x-axis? So it's going to be some straight line. Anywhere. Right? So this is v equal to c line. Let's draw this v equal to c line in xct diagram with some other color. Now x prime could be any line. It's a straight line because it represents rectilinear motion of S prime frame of reference with respect to S. So it could be any straight line, anywhere. Just any of these could be x prime. So now since it is a straight line, first thing is characterized. The second thing that characterizes this straight line is that what is the slope of this straight line. So if I want to measure the slope of the straight line with respect to x-axis, that is I measure this angle tan theta. What would that tan theta be? That tan theta for this x line, x prime line will be any ct by x. But what is this x prime? Now it has to satisfy this constraint. So it cannot be any theta which is ct by x, but a tan theta that will be such that it has to satisfy these two constraints. So I have to take the ratio of ct by x from here. If I take the ratio of ct by x from here, I get the ratio of ct by x from here to be beta. Now beta is actually b by c. So beta is actually less than 1. So this tan theta, which is the angle, tan of the angle that this x prime should make with x-axis, is beta, which is less than 1. Right? So what would this, so that means it cannot be any of these lines, but it is a line which you would see if you see with respect to v equal to c. has to be somewhere here. Has to be somewhere here. I'll wait for 2 minutes. Do you get it now? Anything you want to ask. I'm not in any hurry. I really want you to understand this particular, the other three problems are very simple, right? You can find Doppler effect between two objects which are at an angle with each other in any of the book. I don't need to do it here, right? Second problem is also very straightforward. Third problem is just conservation of momentum and energy. But this is something that you really need to understand, is something you have not done before. So you take your time to understand this. Now I'll wait for 2 minutes for you to, now on your own, I'm going to do that. Now on your own, try to think of what would CT prime look like on this axis. Then you will understand, then you will be able to figure out whether you've understood it or not. Just try to do it. You know, the problem is I can't see you doing. I really feel that cute. Holly. Okay, so now how do I represent CT prime on this? CT prime corresponds to x prime equal to 0. So CT prime should be such that it satisfies these two conditions. First thing, again, CT prime will be a straight line. Why? Because CT prime would represent world line of a particle which has coordinates 0 CT prime. Since this particle is at rest with respect to frame S prime, it continues to remain here. And with respect to S frame of reference, it has a constant velocity V. So it's rectilinear motion. So again, CT prime world line would always be a straight line. Now again, this could be any straight line. It could be a straight line which can be here. It could be a straight line which can be here. It could be a straight line which can be here. So which straight line it is exactly? It is a straight line where the slope of this straight line with respect to x-axis would again be what? The slope of the straight line with respect to x-axis would again be CT by x. But now this time CT by x has to satisfy these two conditions. So CT by x comes out to be beta. Hence it is greater than 1. So this angle, let's say I call, it makes with x-axis is phi. It has to be greater than 1. So that means it is not any line, but it is a line which lies beyond this light cone. So this is phi. Now, as I said, I can also find its angle with respect to the CT axis. Then that angle will be nothing but ratio of x upon CT, which in this case turns out to be again 1 by beta. Sorry, this will come out to be 1 by beta and this comes out to be beta, which is again less than 1. So it's the same angle. So CT prime. So x prime and CT prime are going to look like this. So your S prime frame of reference. Now it is very clear every time I have been telling you that it's a non-linear, it's a transformation which is not like linear, and hence you see it's like a curvilinear coordinate where x prime and ct prime are now, if you look at with respect to x and ct, are not at an angle. So you must understand this is how x prime and ct prime would look like to an observer in the lab frame, in the xct frame of reference. In the frame of reference of the particle, x prime and ct prime would be mutually perpendicular to each other. And x and ct would look something like this. Now, if you go ahead and you think of on the same grounds, so if this was with velocity some v, and you had another frame of reference s double prime, which was moving with velocity v double prime, then depending upon v double prime is less than v prime v, or v double prime is greater than v, you'll again get two sets of lines which would be something like this. Let's say that is v, this is the case where my, let's say v prime, v double prime is greater than v. So my s double prime frame of reference looks like this. And as v approaches c, you approach the light cone. As you approach v equal to c, these two lines, they merge into your light cone. Why? Because then that's going to represent your photon. That's going to represent world line. or the frame of reference of your particle, massless particle moving with velocity equal to c, right? Now, if you are able to draw the world map, you can also draw or mark coordinates of any event x, ct. How will you mark its coordinates in S frame of reference? Is by drawing lines parallel to ct to get its x, and x to get its ct. For the same particle, what would be its coordinates, corresponding coordinates, which are related to x and y by Lorentz transformation? How will you get them? You will get them by drawing lines parallel to ct prime. That gives you x prime. And x prime. So that's going to give you ct prime. If you are able to draw its coordinates, then whatever its world line is, true world line is in xct, you can map its world line in S prime frame of reference. You can see that if it is a straight line motion anywhere here, then what would be its motion, what its motion would look like in x prime frame, xct prime frame of reference. Or if it's some arbitrary world line, you will be able to map that arbitrary world line onto your S prime frame of reference, right? I think we'll have to do only this question today. And I hope you've understood it. You should actually take some time and try to redo this question on your own. This is a very important and interesting question. Why? Because this graphically represents, it helps you visualize what do you really understand by Lorentz transformation, right? So you can see this is a combination. That's what we've been saying, that I've been saying from the beginning, that you can see Lorentz transformation as some rotation or as some transformation, right? So what you really mean by that is to represent your new coordinate system on your old coordinate system. I can wait for 2 minutes. If you want to ask anything in particular right now, I would suggest that you should immediately try to do this question again on your own and think about it.
Ma'am?
Yes, Fiona?
Ma'am? Ma'am, this X prime and CT prime are two of the possible world lines that are possible in the S prime frame of reference, no? Two. Like, there may be many other world lines, no?
No. So these are two unique world lines. And X prime, if you view this world line in X CT frame of reference, it's a world line of a particle which is at rest with respect to, which is moving with respect to S with a velocity v, and it started with some coordinate x prime. So it continues.
And so these two so this X prime and CT prime are the world lines for two particular particles in S prime frame of reference.
Yeah, you have to see that. Now, see, that's exactly what you mean by, so if you think of what would X prime be, if I view it in X CT frame of reference, is something that's going to satisfy a set of equations, right? And CT prime would be, it's going to satisfy some other set of equations, no? Which are given by, so both these.
Got it, yes.
Yeah. So they truly represent, but in both cases, if you just think about, in both cases, it really, it's like you can actually draw. If you just think of a straight line, if you think of that a particle is moving with a constant velocity v in x ct frame of reference, its motion will always be represented by a straight line. And there can be infinite such straight lines. I've been telling you that again and again. You can actually draw infinite number of straight lines in your XCT frame of reference. What truly is the world line of a particular particle will depend upon its initial conditions. And that's what is going to take it to a final point, is when you find the equation of motion of this straight line. So all these represent equations of motions are straight lines only, right? But which straight line the particle will take will depend upon its initial condition. So this particular corresponds to something that started at x prime at time t prime equal to 0. And it will land up here. This represents something that started with x prime equal to 0 at some t prime equal to 0. And it lands up along this straight line. You can actually draw infinite straight lines in XCT frame of reference. But which one is the particle's true world line will depend upon its initial condition. Now I am interested in two particular initial conditions. One that corresponds to x prime axis and the other that corresponds to ct prime axis. How can I visualize x prime axis? I can visualize x prime axis as something where my particle started with x prime at time t prime equal to 0 and remains on x prime. So it represents x prime axis. This represents ct prime axis. Any other world line will also represent. So if I think of it like this, I can have another straight line. But this won't be x prime or ct prime. This would be some combination, some relationship between x prime and ct prime, but it will still represent a straight line. Right? So it will depend upon what are the initial conditions. So that's why I'm saying this is something which is very interesting to see, is how to draw the world map, right? You should think about what I'm trying to say.
Ma'am, for the given particle here, which is moving with v in s frame of reference, that would just be a line parallel to ct prime, right?
That would just be a line
Parallel to ct prime
so
here.
No. Okay, again you are confused. It would depend upon what is its initial condition. Even this line represents a particle which is moving with constant velocity v. Even this line represents a particle, straight line of a particle which is moving with velocity v. As I said, there are infinite such lines. Which world line will represent a particular case will depend upon its initial condition.
Okay, so the given particle can be represented by like the different lines in this
Exactly. And I exploited two of them.
cases.
Two of the cases which interest me. One is x prime axis, which corresponds to ct prime equal to 0, and the other which corresponds to x prime equal to 0 and some ct prime. Because these two axes also represent world line of this same particle.
Got it, ma'am.
That's okay. I can redo the whole problem all over again in the next class, because this is something important to understand. But I will suggest you just think about all that I just said, is that you can have infinite straight lines. X prime is one peculiar such straight line, and I've exploited that fact. Ct prime is another peculiar straight line, and I've exploited that fact using my Lorentz transformation. Right? So what I'll do is, I'll stop here. And you can try to redo this question on your own. And if you want me to redo it next time, next tutorial class, I can do that. Okay, so we'll stop here because you have another class. Is it okay? Can I stop here now?
Yes, ma'am. Thank you, ma'am.
Okay.